Hi class. You guys are in the middle of activity 2 in physical computing. So this past week in class you built a circuit with an LED and a resistor, the limit current that flows through the circuit, and you wrote a sketch that makes that LED blink. And when you come back to lab next week, you're going to be modifying that circuit, adding to it a second circuit that is composed of a temperature sensor, and then writing a sketch that makes the two parts work together to make this temperature warning system, so the LED turns on if the temperature rises above a threshold. All right, so that's what you guys are doing. What I want to do in this video is I want to review some of the material from the LED circuit. So I'm going to build it again just to make sure, I'll give you another pass at this circuit so you understand everything that's going on. Then I'm going to write a sketch that makes this LED blink, and then I'm going to modify the circuit to make it work with a temperature sensor, and then show you what kind of data the temperature sensor is sending and how to make sense of it in a sketch. And so you can convert the voltage signal that the temperature sensor sends you into a actual temperature. All right, so that's what I'm going to do. So what I'm going to do is not exactly like what you just did in lab, and it's not exactly like what you're going to do next week, but it combines elements of both of these weeks in lab, and should help guide you and give you some more of a foundation in the principles that are going on here, building circuits, writing sketches to make them work. All right, so let's get started. The first thing I'll do is I'm going to sketch out the circuit I'm going to build, then I'll build it, show it to you, and then I'll write a sketch that makes the LED and the circuit blink. All right, and then we'll modify it for the temperature sensor. All right. Okay, so I'm going to draw a circuit schematic that looks very similar to what was in the lab activity. So you're going to start with providing power to the circuit from a digital pin, and you guys are using digital pin 7. There, I drew it a little bit better. And then a wire from digital pin 7 on the Arduino is going to go to your breadboard and connect with a resistor, which is about 200 ohms in size. And then the resistor will be connected to a light emitting diode, which then is connected to 0 volts or ground via another wire on your Arduino. So that's the circuit, but there's going to be one more wire here. We're going to add a wire right here and connect it to analog pin 5 on your Arduino board. And we're going to use this wire to monitor the voltage between the resistor and the LED. So if you think about what happens here, 5 volts is supplied by the digital pin, 5 volts here. Some of that voltage, it'll turn out to be about 3 volts, gets used up by the resistor, and then 2 volts remains for the LED. So what we're going to be measuring with this extra wire here connected to the analog port is the voltage that's supplied to the LED. It's approximately 2 volts of voltage. All right, so that's the circuit schematic. Let's build the circuit, and then we'll write the program to make it work. Okay, so here's my Arduino board and a breadboard. So the first thing I'll do is I'll run a wire from digital pin 7 to one of the columns on my breadboard. And then I'll plug my resistor into the breadboard. This is a 200 ohm resistor. So that one pin is in the same column as the red wire. So it's connected to digital pin 7. And the other pin is in an adjacent column. Then I'll plug my LED in, and the long pin goes over here, and I'm going to put it in the same column as this wire of the resistor. So now the resistor and the LED are connected here, and then I want to connect back to ground. So I'll do a black wire from the right side of the LED back to ground. So current, when digital pin 7 is turned on, current will flow through the red wire through the resistor, through the LED, and then through the black wire back to ground. I'm just going to switch that around. Go. Put the wire behind the LED. Makes it easier to see. All right, so then the only thing I want to do is I want to monitor the voltage right here between resistor and LED. So I'll plug that wire in to the same row where the resistor and the LED are connected, and then that'll go over here to analog pin 5. That's it. That's the circuit. All right, we're ready to go. So now let's open up the IDE and write a sketch that makes this LED blink. Okay, so here I am. I got the Arduino IDE open, ready to go. I got a completely new sketch. So what I'm going to do is I'm just going to start from scratch. I'm going to build this sketch that makes this LED blink completely from scratch and talk you through it. Maybe hopefully this will give you a better understanding of how the parts of the sketch work together. All right, so this is an Arduino sketch, so I know that I'm going to have a setup function. So I'll put the bones of that in there. And I know I'm going to have a loop function. So I'll put the bones of this in here as well. Let me make the text bigger. Okay, I have my loop function. Say it with me. The setup function runs once, after which the loop function runs over and over and over again. Okay, so I'm going to be using digital pin 7 here. So I'm going to create a variable, and I'll just call it my pin, and define it to be equal to 7. All right, and then down here in the setup function, I'll do a pin mode, my pin, and so my choices here are I can make this pin an input or an output. Now, what actually happens when you make a pin an output is you're putting that pin in what's referred to as low impedance state. And as an output, we usually use a pin to supply current to a circuit to turn something on or off. But you can actually use that pin as a sink for current as well, and we'll probably do that at some point this semester. But we're setting this pin up as an output in this case because when we turn it on, we want it to supply 5 volts to the LED circuit to make the LED turn on and off. All right, and I got a typo here. It's not by pin, it's my pin. There we go. And I remember my semicolon. All right, if I come down here in the loop. The first thing I'll do is let's turn the pin on. Let's turn the digital input-output pin 7 high. So that's a digital write, my pin high. All right. So when the sketch gets to that point, pin 7 will be set to 5 volts. I'll delay 1 second. Then I'll set the pin low to turn it off, and then I'll wait another second. Okay, so I know you can't see this yet, but I'll show you in a second. So I'm gonna upload my sketch. After I save it, it's compiling, it's compiling, it's compiling, it's uploading, and it's done. And so now I'll flip the camera. There it is. My LED blinks on and off, once every second. Now I haven't done anything with this analog pin yet. So again, we're going to use analog pin 5. So let me declare and initialize a variable to store 5 so I can reference it later. And then what I'm going to do is, let's see, last week in lab what I had you do is write another program or another function called read and print voltage, I believe. So let's do that. Okay, so in this function, one thing we're going to do is we're going to do a call to analog read and store the value that we get into a variable called analog value. Okay, and let's print that to the serial monitor, like so. Now, I haven't initialized my serial communication yet, so I'll come up here to the setup function and do serial begin 9600 bits per second. All right, so now I can use serial print line down here. And so let's run this now. I'll upload it. Well, nothing's happening yet because I've written this function, but I don't use it anywhere. Remember, this function doesn't, what happens in the sketch is setup runs once and then loop runs over and over and over and over and over again. So if something isn't in the setup function or in the loop function, it never happens. It never happens. So I have a situation here where I defined this other function, read and print voltage, and it's sitting down here, but I'm not using it. So I got to call that function in the loop. So I'll put it there right after I turn the LED on. And I'll call it again when I turn the LED off. So, you know, this is why I wrote a function. I'm doing the same thing multiple times. Instead of having to write out the code to do that same thing multiple times, I just write it once, and then I call that function. I write it once as a function, then I can call that function whenever I need to. Save, and let's upload it. All right, so now if I open up my serial monitor, you'll see it's now you can't see the LED turning on and off, but I'll tell you, when the LED is off, we get a number 0 reported, and when the LED is on, we get a number 367. So, sorry. So what we have here is, I'll close that. When the LED is on here, and we set the digital pin high, we get 300 and something. When it's off, we get 0. So remember, this number that I'm getting from analog read is a number between 0 and 1023, and it corresponds to a voltage between 0 and 5. And the voltage is what we usually care about, not the number. But that's how an analog to digital converter works. It converts a number that's on a continuous scale, in this case it's voltage between 0 and 5, into a number on some other scale. In this case, 0 to 1023, because it's a 10-bit analog to digital converter that we have here on our microcontroller. All right, well, let's see. So we don't really care about analog value. What we care about is what the voltage is that corresponds to that value. So we want to convert. So again, analog value is a number between 0 and 1023. So we can think of it as, you know, in fractional terms, how big is the analog value that's being read by our analog to digital converter on that range? Well, it's the ratio of what that value is divided by 1023. And then we want to convert that into a new range that's between 0 and 5. So that means we'll multiply that number by 5. And now I got to do one more thing here. Since analog value is an integer, I got to convert its data type to a float so that I can get an answer here that has decimal points. between 0 and 5. All right, so now I can print that out. And I'll upload this after I add the semicolon I forgot. Okay, so this is what you guys saw before. When the LED is turned on, the analog read is giving us a value of 367, 368, right around there. But that corresponds to an actual voltage of about 1.79. All right, that's what we're seeing here. So if you think about the number line, what I'm saying here is on one number line, the ends are 0 and 1023, and 367 is at the same place on that number line as 1.79 is on the number line that goes from 0 to 5. That's what this math here is doing. It's converting a number on one range to the corresponding number on a different range. So a number 367 on the range 0 to 1023 to a different number 1.79 on a different range 0 to 5. And that's the voltage, 1.79. All right, so in other words, when the LED is turned on, it's using about 1.8 volts to turn on. All right, the rest of the voltage, the other 3.2 volts, is being utilized by the resistor in order to prevent the LED from blowing up on us and burning out. All right, so now let's go back to the circuit, and I'm gonna show you how we'll replace the LED with the temperature sensor, and then replace the resistor with just a bigger resistor, and then we get basically the same circuit, but with two different components, and then we'll come back and modify the code to see how we can use this analog read to figure out what temperature is. All right, so here is the temperature sensor, and the temperature sensor is utilized with a 1,000 ohm resistor. So the first thing I'll do is I'll pop out the 200 ohm resistor and put the 1,000 ohm resistor in there. Now I will say that, you know, when you guys come to the lab, you're not going to do this. You're actually going to build a separate circuit somewhere else on the breadboard because you need both of these circuits at the same time. But I don't. I'm just trying to demonstrate here. So I'm taking the LED circuit away, pop out the LED, and now I got to pop the temperature sensor in. So one thing is that the temperature sensor doesn't have 2 pins, it has 3. And I got to look at the data sheet to see which 2 I want to use. It turns out that this pin over here is so you can build a circuit and calibrate it a little bit better. We're not going to use it. I just bend it out of the way. Don't do that if you can help it, but I'll just bend it out of the way. And then these 2 pins, the middle one gets connected to the resistor and the wire going to the analog pin, and the one on the right gets connected to ground, like this. So that's it. Now I've modified my my circuit to work with the temperature sensor here. All right, so let's go back to the code and see what happens. Okay, so I'm back here in my sketch. This is exactly the same sketch that we were just running the LED circuit on. And if I upload it and take a look at the serial monitor, we'll see similar behavior. So now the temperature sensor is switching on and off, and when it's off you get zeros. When it's on you get an analog read value of 634-ish, and which corresponds to a voltage of about 3.1. All right, well, what does this voltage mean? Well, one thing I'm going to do here is I'm going to change the sketch because we don't need to turn the temperature sensor off. We want to leave it on. So I'm just going to comment out. Just highlight that, right click, and select comment. Just comment out the part of my loop that turns the digital pin off, because I don't want to turn my voltage, my temperature sensor off. I want it always to be on. I could even move this digital write my pin high line up to the setup function, because once my temperature sensor, why don't I do it? digital write my pin high, because once the temperature sensor is turned on, we just want it to stay on. All right, so I'll move it up there. It's on once, it's always on. And so I can put it in the setup function, because this only gets run once. All right, so now let me upload this, and then we'll take a look again. And here we go. All right, so now it's always on. You're getting the analog read value and the corresponding voltage for that analog read. Now I'm going to hit the temperature sensor with a blast of hot air from a heat gun. I know you can't see this. That's what I'm doing. What do you notice happening? Do you see the voltage going up? And I'll turn it off. You'll see the voltage go down. So as the temperature sensor warms up, the amount of voltage that it's using also goes up. And this is how it's designed to function. It's designed to function in a way that the voltage it consumes is directly proportional to the temperature in Kelvin. Okay? So the exact conversion here is, when I look at the data sheet, is every 10 millivolts of increase corresponds to 1 Kelvin. 1 Kelvin. So if we multiply the voltage by 100, we get the actual temperature in Kelvin. All right, so 3.23 volts actually means temperature of 323 Kelvin. All right, so I'm going to add that to my program here. Read and print voltage. I'll add another line down here in my function. It'll be a float, which is temperature. And so the temperature equals the voltage times 100. And you know what? I'm also going to, so that's Kelvin. I'm going to convert to degrees Celsius by subtracting 273.15, because that's absolute zero. All right. So multiplying the voltage by 100 converts into temperature in Kelvin. Subtracting 273.5 converts Kelvin to Celsius. And then I'll print that. So I'll upload this. All right. So there's a lot here. Let's just show, so you can see there's another line each time stuff's printed here, which is showing the temperature. Let's get rid of the other stuff. I'll just comment these lines out. And to be a little more fancy, why don't we do this? Let's actually print out what we're looking at. So I'll print out first temp degrees C, and then I'll actually print out the temp. So my temperature sensor is reading 35 Celsius, and this hasn't been calibrated, so it's probably, it looks like it's a little on the high side. But if I blast it with the heat gun again, you see it going up quite quickly. Whoa. Don't want to melt anything. Ooh, everything's hot. Okay, don't want to melt anything. All right, but my temperature sensor is working, and I've converted what it's, let me emphasize this again. The temperature sensor is a device where the temperature in the room, the temperature of the device, influences how much voltage it utilizes. So the actual signal that's being sent to the microcontroller is not temperature, but voltage. And then in my sketch, I convert that voltage back into a temperature because I understand how the temperature sensor works. I know that it consumes a voltage proportional to temperature in Kelvin. So I can go back and forth. Okay, so that's all I want to show you in this video. I just wanted to go through some of these things that you've been doing again, give you another pass on making this circuit and writing the sketch that makes it work, and give you a little bit of help on integrating the temperature sensor when you come in next week. All right, I will see you then.